Hey class, today we're going to deal with factoring quadratic expressions, which is found in section 4-4, part 2 of your book. We're going to find the binomial factors of quadratic expressions and factor special quadratic expressions. So in example 3, we're asked to find the factor form of each expression. So with these two examples, we're going to follow the same example that we were doing with part 1, which is the AC method. Remember in the beginning I told you guys to identify A, B, and C. So A is 2, B is 11, C is 12. Okay, after we identify those three, we're going to multiply A times C. A times C here is going to give us 24, and then we write our factors, hoping to get 11. So here we go. 1 and 24, 2 and 12, 3 and 8, 4 and 6. The factors that will give us 11 are 3 and 8. So remember, 3 and 8 need to replace 11x. So really we're replacing it with positive 3x and positive 8x. So remember, the first and the last are rewritten. So 2x squared and positive 12 are rewritten. And then 3x and 8x are rewritten in the middle. Alright, we group the first two and the last two. I can take from 2x squared and 3x and x, and I'll still be left with 2x plus 3. The greatest common factor of 8x and 12 is 4. And again, what's left over is 2x plus 3. So we've done this problem correctly. We know we have because we see that these two factors are the same. So the first factor is 2x plus 3. And the other factor is what's not in parentheses, which is x plus 4. And we are done. Okay, let's do this same method again for the second one. So again, we identify A, B, and C. A is 4, B is negative 4, C is negative 3. Okay, AC will give us negative 12. So let's just find all the factors of positive 12, and then we'll need to figure out some combination to give us negative 4. That's 1 and 12, 2 and 6, 3 and 4. So the combination that's going to give us negative 4 is 2 and 6, but we have to figure out how. How can we get negative 4 from 2 and 6? Well, we can do that or get that by having a positive 2x and a negative 6x. Okay, because 2x minus 6x is negative 4x. So we're going to rewrite. Remember, the first one is 4x squared. And the last one is negative 3. And then we're going to put 2x and negative 6x in the middle. Okay? We're going to group. And that's, I apologize, that's plus 2x. Alright, so for the first one, I can take 2x out. And I'm left with 2x plus 1. With the second one, I can take out a negative 3. And I'm still left with 2x plus 1. That way when I group, 2x plus 1 comes out, and what's left over is 2x minus 3. And we're done. So let's try this again and try 3. Alright, and try 3 again, we're going to find that A, B, and C. So A is 4, B is 7, C is 3. AC would give us 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. The factors that would give us 7x would be 3x and 4x. So I need to rewrite 4x squared and positive 3 and put 3x and 4x in the middle. If I group the first two and the last two, I can take an x as the greatest common factor of the first half, and I'm left with 4x plus 3. In the second one, it doesn't look like I have a greatest common factor, but when it looks like I don't, I can at least take out a 1, a positive 1 here, and I'm left with 4x plus 3. And I've done that correctly because I have 4x plus 3 as a common factor of both. And then what I'm left with is x plus 1. And I'm done with that one. Last one of this section. A is 2, B is negative 7, C is 6. Okay, AC would give me, again, 12. So 1 and 12, 2 and 6, 3 and 4. What combination now is going to give me negative 7? Well, the only way I'm going to get negative 7 with the combination of 1, 12, 2, 6, 3, and 4 is both 3 and 4, but they cannot be positive because if I had both positive 3 and 4, I'd get a positive 7. So they have to both be negative. And I know that they could be negative because if I multiplied negative 3 times negative 4, I would get positive 12. So that does work. So let's rewrite 2x squared and then positive 6. And then negative 3x and negative 4x go in the middle. If I group the first two and the last two, I can take an x from the first and be left with 2x minus 3. With the second one, I can take out a negative 2 and still be left with 2x minus 3. When I'm done, the two factors in parentheses are 2x minus 3. And then what's left over is x minus 2. And we're done. All right, looking at example 4, we need to talk about factoring a perfect square trinomial. All right, so to know if you have a perfect square trinomial, you would notice that this first term is something squared, meaning if I look at it now, I should be able to take the square root and I shouldn't have any funky rationals or radicals, excuse me. Same with 36. That one should also be a perfect square. And then the center number should either be a positive or negative 2 times the first term times the second term. And specifically the square roots of the first term and the second term. If that is the case, if it is positive 2ab, your answer would be a plus b squared without having to go through the whole process, okay? The next one would be a minus b squared if I had negative 2ab. So let's look here to see what we have and then we just put it in the correct form. Is a perfect square? Yes. 4x squared is a perfect square. It would give me 2x. Secondly, is 36 a perfect square? Yes, it is. It would give me 6 if I took the square root. The last thing we need to do is determine if the middle term is negative 2 times the first term times the second term. So let's see, is that true? Negative 2 times 2x times 6. Is that true? Yes, it is. It will give us negative 24x. So since that is the case, we will use our second expression. And as our answer, we will get our a is 2x minus our b is 6, and then it's squared. And we're done. Now, by the way, this is a shortcut, so if using this shortcut does not work for you, go back to using the AC method because it will work. Okay. However, when you are dealing with timed assessments, it's best to use or learn the shortcuts possible so that you can speed up your time. Okay, let's test it out on the second one. So again, we check to see if the first term is a perfect square. We check to see if the last term is a perfect square. And then we check to see if the center term is positive or negative 2 times the first term times the second term. So let's see. Square root of 64x squared is 8x. Square root of 1 is 1. So let's determine if the center is negative 2 times 8x times 1. And yes, it is. That's what gives us negative 16. So our answer here is going to be 8x minus, because I used the minus from here, and then 1 squared. And we're done. All right, in example 5, we're practicing factoring a difference of two squares. Once again, this one is a shortcut, and so it's fairly simple to learn. So let's just look. What we notice here is that this setup is a little different, and so that means that the answer will look just a tad bit different than what we're used to. Okay, 25x squared What you want to first determine is if the first term is a perfect square. Next, you want to determine if the second term is also a perfect square. If they are both perfect squares, and notice that this is called a difference of two squares. That makes sense. This is a difference, meaning subtraction of two squares. If that's the case, then its final setup will be a plus b and a minus b. So let's check. 25x squared, if I took the square root of that, I'd get 5x. And 49, if I took the square root of that, I'd get 7. So, yes, they are both the difference of two squares. So our final answer will be 5x plus 7 and 5x minus 7. Let's try that again. Again, we check to see if the first and the second term are perfect squares. And again, we should be able to easily recognize this because it should form a difference of two squares. And the squares will be 16x squared, the square root of that is 4x, and the square root of 81 is 9. So this will give us, yes, they are both perfect squares, and they are a difference of two perfect squares. So our answer is 4x plus 9, and then 4x minus 9. And we're done. Guys, that's it. As always, if you need any extra help, just come and see me for tutoring.